Hello, welcome to Introduction to Java Programming. In this session, we will discuss about the jump statements, break, continue, and return. Let's begin. So, as part of the basic programming constructs of Java, now we have arrived at the last part, that is jump statement. By the name, jump statements will jump from one part of the program to the other part. Let's demystify what is break, what is continue, and what is return. Yeah, so these three statements, namely break, continue, and return, are the keywords. So break is a keyword, continue is a keyword, return is also a keyword. And break we have already seen in the switch block. Whenever you are using a break in the switch block, you are coming out of the block. So that is one use case that we call as a labeled break. When used in the switch, it will come out of the switch block. And there is another use case of the break, that is unlabeled break. That means you can use this break in loops actually. So that means in loops you don't have any labels, right? Only in the switch you will have the case labels. So that's why we call this as a unlabeled break, which will be used in the loop. Whenever break is there in the loop will get exited. So we will come out of that particular loop body. We will understand that with few examples. Then coming to the second one, continue. So continue is actually one of the jump statement which is used to skip some loop iterations. So your loop is executing for a number of times and you want to skip some loop body executions. You can actually use continue. One of the very useful keywords is the continue, and there are good number of use cases, and I will be explaining that with some examples. Then coming to the return. Return has two use cases again. You can straight away use like return. When you say return, it will actually exit from the program, not just from the block. You will come actually out of the program. Okay, and the another use case is return value. Every method in Java, otherwise I can say every function in C and C++ must have to return a value. So that we will specify using return followed by that particular value. So if it is not returning any value, we will specify that with the void. Okay, so in our Java, we write our main method as public static void main. So this main method is not returning anything back. Then we will say void. Void means return nothing. But every method has to return certain value, right? So this actually, this value is returned from a method. I will actually show you the examples of returning a value from good number of methods, because once this basic programming concepts are over, we will actually sailing through the object oriented programming concepts. There we have to define a class and then define methods in the class. Then we will see how a method is actually returning the value back. Okay, so with this, let's actually go to a program to understand the break first. Okay, so this is the skeleton code. I have a class test, and here in the main method, now let me actually write one loop, one for loop. So let's say this for loop is actually starting from let's say 5, and then it's actually going up to 5 less than or equal to, let's say, 100. Okay, and I equal to I plus 5. So what I'm doing actually, I'm using a step over here. Every time this I value will actually step by 5. So first initially 5, then actually I will have 10, then I will have 50 until so on 100 actually, right? So it's not just I plus plus. This is actually I equal to I plus 5. Okay, so I'm going to print actually 5, 10, 15, 20 until so on 100 actually. Whenever I value becomes greater than 100, that is 105, will come out. So meanwhile, what I want to do is I just want to print actually here system.out.println, this I value I'm going to print. So I just say print here, and then I will actually give some space. Okay, so that's how it is actually printing, right? So now you can actually see the output. Once I come out, I will actually have my PL statement that just printing a new line actually. So let me compile this Java C test.java. it will get compiled, no problem. And when we say Java test, you can actually see the values are getting printed. So 5 to 100, right? So this is how a normal for loop work. But now what I want to do is I want to use actually break here. So break actually exits from the loop. So now what I'm going to do is I just want to break when the value is for example, the I value is 50. Whenever the I value is 50, I want to come out actually, right? So now what I do is I will write a condition if I equal to 50. Okay, just break. If I equal to 50, I'm saying break. Actually, it is printing me 5 to 100, right? But whenever my I value becomes 50, exactly matching. Otherwise, I can say I greater than 50. Okay, then I should get actually. So better actually is to write something like I greater than or equal to 50. Not just I equal to 50, I greater than or equal to 50, just break. Now what happens? So 5 to 50, it will get printed. Whenever this I value, every time it is getting updated, right? It becomes greater than 50, it will come out. So when it comes out, we just have a new line. So this program prints 5 to 50 only, not 5 to 100, but it will 50 only. It will print only till 50 because this is how I am actually using break here, right? So break makes the jump from this block. Okay, jump from this loop body or loop block, whatever I can say, right? So let me compile and show you that it will work, and you can actually see the importance of the break over here. Now you can see here 5 to 50 only. Okay, so whenever certain condition is met, I want to come out actually. So then we can actually use break. So break is used to break the flow and comes out of that particular loop body. Okay, that is the use case of break. And not just this, what I can do is, if you remember, when we are discussing a while, we have written actually one program to find whether a given number is prime or not. Okay, so this actually solves that problem, but it's not so efficient actually. The code I have written is not so efficient. So I can make it very, very much efficient. So what I can do for that is, to make this very efficient, what I'm going to do is I will actually go up to number by 2. I less than or equal to number by 2. So we know, for example, 10 is my number, and 10 will have no factor. 10 will have no factor which is actually greater than its half size. So 10, 1 is a factor, 2 is a factor, and 5 is a factor. And 5 to 10, there are no factors other than itself. If you take 100, maximum factor value is 50. After 50, you will not find any factor other than itself actually. Right? So I will actually use that logic and I will go up to number by 2 only. And my prime number, it becomes a prime number if it has only one factor. In this case, a prime number has just one factor, right? It just has one factor because I am going up to half only. So by doing this, what I'm doing, I'm making my program more efficient. For example, my number is 1 crore. In the earlier case, my loop is executing 1 crore times. Now I have made off. So I am actually making my loop execute only 50 lakhs times. So I have saved so much of processing power, so much of time, right? So that is one way. Yeah, let me actually show you that it will work. Let me compile, and this is actually main.java. So let me say Java C main.java. Yeah, compile, and when I say Java main, now 30 is not a prime number, then 36 is not a prime number, 41 is a prime number. It's working, right? It's working. So what I did, actually I'm counting till off of that number only, because I know after that there are no factors. Why to unnecessarily waste the processing time? So this is one way. So this has become little efficient. I would like to make so much efficient actually. Okay, so now even though I am giving 1 crore, and in order to test 1 crore, I am actually, my loop is running How many times? 50 lakh times. So I don't want to make 50 lakh iterations when I know that that is not going to be a prime number. What I can do here is, yeah, so here, whenever number mod I equal to 0, I am making count plus plus, right? So here what I do, I will write one more statement here. If this particular count is greater than 1, the count value, that means the number of factors are greater than 1, why unnecessarily we have to run the loop, right? See, the factor is only 1, then it is a prime number. If it is not, if the factors are more than 1, for example, I would like the random number generated is 10. For 10, 1 is a factor, 2 is also factor. When I know that the count value is 2, that means 1 and 2, two factors, it is not going to be a prime number. Why I have to waste the time over there? Why I have to waste the time over there? Right? For example, if you take 50, what are the factors? 1, 2, then you have 5, then you have 10, then you have 25. I need not to count all these factors. When I know that the number is 50, it has more than one factor, 1 and 2, then I should come out. And I have to say, because it's greater, the count is greater than 1, so I need not to run the loop. I will here, if count equal to 1, then it's prime number, otherwise it's not a prime number. So I need not to actually waste the time over here when I know that it's actually not a prime number. Only when it is a prime number, now I have to do all the iterations. That means count is not greater than 1, my loop has to run those many times. When count is greater than 1, then I need not to waste the time actually. Okay, so let me make you once again. For example, the random number generated is 100. Okay, so I'm starting from 1. So 1 is a factor, right? And count greater than 1 fails actually here because count is only 1. Then 2. 2 is also a factor, count is 2. So if count greater than 1, break. Okay, don't stay over there. Count is greater than 1. So it's not going to be a prime number. Just come here and check count equal to 1, no. And it says it's not a prime number. So I'm actually saving number of iterations. This is the most efficient way of writing the prime number program. Okay, so here I am using my break statement. So when I know the number of factors are greater than 1, it's not going to be a prime number, just I am coming out. So how do I come out? By using this particular jump statement break. Now let me show you that it will actually work. Java C main.java, and when I say Java main, now 18 is not prime number, 2 is a prime number, and 53 is a prime number, then 61 is a prime number, then 97 is a prime number, 99 is not a prime number. Yeah, whenever it is not a prime number, it will actually come out with 2 iterations only. See, for example, this case 30 is not a prime number, so just 1 and 2 are the factors and it will come out. It will never actually go to I value equal to 3, 4 until 15. It will not go, because whenever the count value is greater than 1, it comes out actually. Okay, so this is actually the most efficient way of writing the prime number program. So using break actually, and this will become most efficient way of finding a prime number. Okay, so that's about actually the break statement, and let's now move to continue. So continue statement is used to skip certain loop iterations. What do you mean by skipping the loop iteration? So let me actually take up for example, a simple example, a continue demo over here. I will write actually a for loop. So here what I'm doing, int I equal to 1. Yeah, I less than or equal to, let's say 50, and I plus plus. Okay, so now the program logic is actually to print all the numbers. Okay, so if I do this program, what happens? I equal to 1, I less than 50, I plus plus, I value. So I will get 1 to 50, right? I will get 1 to 50. So I just want to show you that. Yeah, so this is going to get print 1 to 50. Yeah, so this is the code. Let me actually compile and show you that it is going to print you 1 to 50. So the code name is demo. So Java C demo.java. Now let's run it, Java demo. and you can see 1 to 50 are getting printed. Fine. Now I want to skip certain loop iterations. I want to skip certain iterations. Okay, so what I want to do is I don't want to print the numbers between 30 to 40. Numbers between 30 to 40. Okay, here I am getting everything, right? 30 to 40. Otherwise, I can say 25 to 40. So 50 numbers I want to skip. The 50 numbers I want to skip. Okay, so how do I do actually? So now I can make use of this continue statement. So what I'm doing here is if I'm writing a condition, I value is greater than 25. Okay, and yeah, and we have to write like this, right? Ampersand, and I value less than or equal to 40. So I want to skip 26 to 40 actually. Okay, whenever I value is greater than 25 and I less than or equal to 40, I just say continue. Let's understand this carefully. Let's say continue. Now what is going to happen actually? If I greater than 25 and I less than 40 continue, so I am saying skip loop body execution. Skip loop body. So what is there in the loop body? Printing a I value, right? I'm actually skipping this whenever these conditions are met. So the loop is actually starting from 1 and going up to 50. It will print up to 25, no problem. 25 onward, what happens? Continue is going to get executed because this condition is true. So 26 to 40, that means 15 times, it skips this particular line actually. This is what skipping the loop body or skipping the iterations. Then whenever I value becomes 41, then 41 to 50 it again prints actually. So this is how this particular continue will work. Let me actually show you that. Yeah, Java C demo.java. And when I say Java demo, let's observe the output here. You cannot actually see 26 to 40. See here. So let me make this bigger so that everything will be in a single line. So after 25, after printing the 25, my continue is getting executed. It is skipping this particular, sorry, skipping this particular loop body. So 25, after 25, we have 41 to 50. Fine. So this is how the continue will work. And not this program, I just actually tell you a good program to do this. So continue demo, what I want to do is I want to print capital A to Z and small a to Z collectively. Okay. So I want to print capital A to Z and small a to Z using a single loop only. Using a single loop only. So this is one of the good use cases of actually continue statement. So what I do over here is I know I want to print capital A and go up to small z, capital Z, and then start with small a and go up to a small z. So I know we already have seen about this Unicode characters. So 65 is capital A, right? And 90 is capital Z. Okay, so 90 is actually capital Z, and then 97 is small a. 97 is small a, and 122 is actually small z. Now what I have to do is I have to take care of the values between 90 and 97, that is 91, 92, 93, 94, 95 and 96, because these are all special characters. Okay, all these values are special characters, so I have to skip them actually. Okay, so now I will start my loop straight away. I equal to 65 and I have to go up to the last value, that is 122 I plus plus. But here what I need to do is whenever my I value is actually greater than 90, that means 91 to 96 I have to take care now. So I greater than 90 and I less than 97. I less than 97. So that means 91 to 96. Those are the special characters I have to continue. That means those whenever that is met, I don't want to print actually. I don't want to print the character. Okay, system.out.print, and yeah, so I need to print the character. So I will actually typecast char of I, and after that I'm going to give some space. Okay, so now what happens when I equal to 65, it will get printed. Okay, till 90 that will get printed. Whenever it is 91, continue. So skip this, so it will get skipped. Actually, this loop body will be skipped for I value greater than 90 and I value less than 97. That's the idea actually. So this is how we can solve this problem. Let me actually show you that this is going to get work. So let me say javac demo.java, compiled successfully, and when I run, now you can actually see A to Z capital letters and immediately followed by A to Z smaller case letters. So this is one of the interview questions, and we can actually make use of the continue and simply we can solve it. Of course, there are other ways to do this problem, but this is the simplest way to do this. So this is the use case of continue statement. Let me actually tell you one use case of the return statement, and the return value we will be seeing in our next sessions, because we will be continuously writing the methods. Let me actually tell you one use case of return. Yeah, so let me actually go to one program where I can actually tell you about this. I will actually write return demo. So I will save this as a return demo. This is not just for each demo. Let me actually make a return demo. Okay. So it is a return demo. So now I need to change this as a return demo. And here I don't have any array or something. Yeah, so what I'm going to do is I will generate two random numbers. So I have the code already to generate random numbers, right? I just generate two random numbers here. Yeah, so int I just say n1 equal to 1 plus, and let me keep 100 over here, and then it is going to give me 1 to 100, and the same thing I'm going to have n2. This is n2. This is also going to generate us 1 to 100 random numbers. Fine. So now what I want to do is, yeah, so I just want to find the result equals to n1 by n2, n1 by n2. Okay, and I just want to print this. So n1 by n2, and I'm going to print the result actually. Okay, so after that, I just want to find out some product that equal to, that is nothing but n1 into n2, and here I just want to print the product value as well. So just I'm taking a simple example to for this particular thing. So since it is actually generating 1 to 100, so I may not get the desired thing actually. Let me actually take 1 to 10 only, and yeah, 1 to 10 only. Now let's see what is the value. What is the value of result and what is the value of product? Okay, this is all integers. You are not going to get any floating values. Yeah, so let me compile this javac return demo.java, compile, and java return demo. Yeah, so first n1 equal to, yeah, so I just need to print actually what are the two numbers, so that will give us understanding. So let me print n1, and after giving some space, let me also print n2. Okay, so that we will understand what are the numbers which got generated. So let me compile again, and let me run actually. Yeah, so 4 and 4 generated. So 4 by 4 is 1, and 4 into 4 is 16. That's fine. And this time 10 and 8, and we got the outcome. So this time, yeah, 6 8. So 6 by 8 is actually 0, and yeah, 6 into 4. So all these cases are working actually. Let me wait for the case which actually I am interested in. I want the n2 value to be 0, and it's not happening so far at, yeah, n2 I want 0. That's all. That's not happening actually. I will go as long as I will be doing as long as I am getting non-zero values. Let me try again. Yeah, I'm not getting the n2 0. So if it is n2 is 0, then we have some understanding. Oh, sorry, 0 will never come, right? Okay. Okay. Yeah, I have made actually here 1. I should remove this one. I should remove this one actually. So I am waiting for 0 to come. Yeah. Okay, so this is just 1 to 9 only. 0 to 9. Actually, I am waiting for 0, but my code actually never produces 0. So that's a mistake actually. Let me try now. Yeah. Java C return demo dot Java. Yeah, Java return demo. So now I will have a chance of getting 0. N2 I want 0 actually, not N1. Let me try. Yeah. So this case you observe actually. Now I got N2 value 0, right? So in all other cases I am getting some output actually 0, 3. 0 by 3 is 0 and 0 into 3 is 0 and 4, 3, right? So 4 by 3 is 1 and 4 into 3 is 12. But here, whenever you have 2, 0, you are dividing n1 by 0. So whenever you divide n1 by 0, divide by 0, you will actually get divide by 0 error, that is arithmetic exception. Java.lang arithmetic exception. That's actually a problem, right? Yeah, so this is actually called a system crash. Whenever your n2 value is 0, n2 equal to 0, it's actually a crash. So how do you save from the crash means? Now what you can actually do is you can actually check here. Okay, so whenever you are reading the values, you can actually do that. If n2 is equal to 0, just return. Okay, if n2 is going to be 0, you are going to get crash, right? So now what I am saying is if n2 is 0, let's not do anything actually. Exit from the program. When n2 is 0, you are going to get crash. Unnecessarily don't get crash. So you don't do this thing. Whenever n2 value is 0, somebody supplied 0, don't do anything. Simply come out actually. Simply come out. Okay. So that's what is actually going to happen. Let's see now. Let's see now. So whenever n2 becomes 0, you will come out of the program. Let me show you this. It's actually taking some time for compilation. Yeah. Yeah, now it's working. N2 is not 0. N2 is not 0. I have to do. Yeah. See, whenever n2 value gets 0, what's happening? Nothing is happening actually. Whenever I know that n2 is 0, I should not divide actually. If I divide, I will get crash, right? So how to safeguard from this? So by writing certain condition statements using if. Okay, so this is the use of return statement. So return statement will make you exit from the program whenever that is actually met. Okay, and there is another statement return with the value that we actually do whenever we are writing methods. Of course, here my main method is returning void. Okay, so if my main method is int, I have to return a value back. So that actually is going to come later when we discuss about methods. Okay, so that's about the jump statements: break, continue, and return. Hope you have understood all these 3 statements thoroughly, and I will see you in the next session where we are discussing about arrays. Thank you.